Hi guys, I'm Roshan Sarda, a UG student of CSE branch. Today I'm going to discuss about the topic of parallel adder with accumulator. Before going to this topic, you need to understand what is adder. So basically an adder is a kind of calculator that is used to add two binary numbers. Here the two binary numbers means it can goes up to n binary numbers. In many computers and other types of processor, adders are used to calculate addresses, similar operations, and table indices in the ALU and also in other parts of the processors. There are basically two types of adder, half adder and full adder. Half adder. A half adder is an adder which adds two binary digits together resulting in sum and carry. So basically half adder is used for the operations for two inputs. We can name two inputs such as x and y, and these two inputs after processing this we can get the output as sum and carry. The adder circuit which will be used to add n bit binary numbers is also called full adder. And this adder means the half adder is less than a full adder and hence it is known as a half adder. This is the block diagram of half adder and the circuit diagram is shown below. A and B are the two inputs and S and C are sum and carry. We got the output as sum and carry, so therefore S and C are the outputs, A and B are the inputs in which we have to do some operations. The sum is given as A bar and B plus A and B bar. So AND operation is used and carry is given as A and B. And the truth table is also shown and it follows the same as operation as sum and carry. Coming to the other adder, which is full adder. Full adder is a adder which add three inputs and produces two outputs. The first two inputs are A and B, and the third input is in input carry as seen. Here, these inputs are we are just giving the names. You can give X, Y, Z, anything as a input names. The output carry is designated as C out, and the normal output is designated as S, which is sum. Here, the same as in the half adder, we get two outputs, namely sum and carry S and C. Here also we get two outputs, sum and carry. A full adder logic is designed in such a manner that can take eight inputs together to create a byte wider adder. That means we are getting three inputs as A, B, and C in. Here we can give different types of bits such as 1, 0 to each other, so we can get eight types of output. As it has follows the principle of 2 raised to power n, and here it is n equals to 3, so it follows 2 raised to power 3, which is 8. Is the circuit diagram of full adder, which is showing three inputs x, y, c in and two outputs sum and carry outs, s and c out. And the truth table for full adder is also shown below. We can make full adder using half adder. Here we use two half adders and three inputs c in, p, q and get an outputs as carry out and sum. And here we use a OR gate. Parallel adder. Parallel adder is a binary adder that is capable of forming sum and carry outputs for addend and augend. Augend means the thing which used for addend. That means there are two inputs A and B. So one is addend and other is augend. Words of greater than one bit in length by operating on corresponding pairs of addend and augend bits in parallel. That is at the same time. So here addend and augend, these two bits are parallelly operated. This is the requirement given here for the parallel adder with accumulators. In this diagram, we can simply see that multiplexer is also used, and the requirements are wiring between ACs, a test procedure to verify the rest of the circuit. So this circuit also have to be tested. This is the simple block diagram of parallel adder. Here FA1, FA2 are simply denotes full adder 1, A1, B1 are the inputs, S1 is the sum 1, C in is the simple carry in, and after that, after the operation of A1, B1, we get S1 and C1. S1 is the sum and C1 is the carry. This C1 also gets operated with A2 and B2 to get S2 and C2 and so on. This is the block diagram of n-bit parallel adder. Here add, you can see in the diagram that AD, which is known as addition operator, it adds x1 and y1, which are the two inputs. Here we are getting two inputs x1 and y1. So add is the function which operates between x1 and y1 to get operated. C1 is the initial carry one stage which we are using for x1 and y1 to get s1. S1 is the sum one clock CLK here denotes the clock, which means that for each single step of operation, suppose x1 and y1 are getting operated, here the clock one simply shows the time x1 and y1 gets operated. So for x1 and y1 we are using clock 1, for x2 and y2 we are using clock 2, for x3 and y3 we are using clock 3, and it goes till xn and y1, which is goes up to clock n. Clear it simply clear the first step of basic steps so that the rest of the steps are independent of first step. Here are the steps which we have to follow for the diagram of n bit parallel adder. First step is clear the accumulator using asynchronous clear print on the flip flops. Here the flip flops are shown as q dash, q, ce, and d. So CLRN is simply a clear print, clear in print. So this means that it basically clears all the initial datas. Load accumulator with X data. Accumulator or register is a simply allotted space so that we can store X1 or input to that register so that it can get operated. Put Y data to adders. Now in the full adder, we have already stored X1 in the register. Now we have to add y1, so we simply put y1 in the full adder, and in the register x1 is already uploaded, so x1 and y1 are added in the full adder, and we get c2 as a carry, sum1 as a sum. Add adder data to the accumulator. Now for giving an example, here it is shown a 3-bit parallel adder with accumulator. Here 3 flip flops are used, so that means if n bit are used for parallel adder, n flip flops are used, so here 3 bits parallel adder are used, so 3 flip flops, we are using 3 flip flops, and 3 full adder also. So c1 is basically the initial sum, add clk means clock, and clear. These have the same work as we have described for n bit parallel adder. X1 is the initial input, y1 is also the first input we are getting so that it can operated. C2 is the carry which we have get after the addition in the full adder of x1 and y1, and s1 is the sum one. And this goes as the same principle of n bit parallel adder. So the formula for s1, or we got the x1 is equals to x1 XOR with y1 XOR with c1. So this principle, it follows the principles of s1 equals to x1 XOR with y1 XOR with c1, and we get the value of sum 1. And this is the block circuit diagram using multiplexer and basic gates so that it can simplify the circuit, and which we are not here in this diagram since it shows the overview, and the flip-flops is the internal diagram and a systematic diagram, and it shows different types of gates such as NAND gate, AND gate, OR gate, and multiplexers, M41E, etc., so that it can simplify the circuit. So thank you for watching this video. Hope you like this video.